Good evening, friends. Today, let me talk on the decision theory, the mathematics behind taking decisions. So, in our college course in BSTAT third year, we were given a paper named as Decision Theory in Statistical Inference, which was taught by late Professor respected Somesh Das Gupta. And we mainly followed this book, Mathematical Statistics, a Decision Theoretic Approach by T.S. Ferguson. Professor Dasgupta used to teach from his notes only, but we followed this book by T.S. Ferguson on Decision Theoretic Approach to Mathematical Statistics. So the mathematics behind taking decisions, let us have some options O1, O2, On, and you need to decide between the options which one to consider. So you have n options to choose from, and you have quantified loss for each option. L1 is the loss for option 1, L2 is the loss for option 2, Ln is the loss for option n. I mean, if you have if you have gains, it's a negative loss. So L1 into Ln includes both loss and gain. Negative loss means gain. So I'm not going to loss functions or those mathematical abstractions, but let's have some discrete options O1, O2, On with with discrete losses L1, L2, Ln. Now we are supposed to choose from the options, one of the options. Now let me look into it in this way. We have several decision rules. Decision rule 1, decision rule 2, decision rule K, which specifies probabilities over the options, and these probabilities can be 0 or 1 also. So that way you are considering a discrete choice bit of O1, O2, On. So you have probabilities P11, P12, P1n for rule 1, which gives these probabilities to these options. And for rule K, you have pk1, pk2, pkn probabilities over the options. So you need to choose the best decision rule. Each decision rule is a probability distribution over the options. Now, for each decision rule, you calculate the risk factor R1, R2, Rk, which is given by summation j equal to 1 to k Lj Pij for ith decision rule. That's the risk of the rule 1. R1 is the risk of rule 1. R2 is the risk of rule 2, and Rk is the risk of rule k. And obviously, the best decision will be the one with minimum risk. You minimize risk and take the best decision rule, which is a probability distribution over the options. So you have quantified loss, you calculate the risks for each decision rule, and you consider the decision rule with minimum risk. So that is the mathematics behind taking decisions in a nutshell. But it has a lot of mathematical abstractions with continuous losses, etc. But I am not going into it. So taking decision, choose decision rule I if Ri is the minimum among R1, R2, Rk. The one with the minimum risk is our chosen decision rule. So that's the decision theory we studied in a nutshell. And few days back I was reading a blog on government decision matrix, which we apply in daily life. So you have options and you have success or failure or unknown, and those come up with different risks. High risk is bigger than 80%, medium risk between say 40% to 80%, and low risk is less than 40%. So this is the priorities you choose. You put priority 1 with when you are sure of success with high probability. Then comes priority 2, when it is unknown to you whether it is going to be a success or failure with high probability. Then you prioritize, you put third priority to a success with medium probability rate. Medium probability is 40 to 80%. Then comes the fourth priority when it is unknown to you but has medium probability. Then comes the success with low probability, then unknown with low probability. And the last option is you are going to be a failure. That comes with low probability, that gives priority 7, and these two are clearly no. Failure with high probability and medium probability are, of course, a no choice system. So this is the Goldman decision matrix which we use in our daily life. I mean, this goes in the back of our minds. I'd stop here. Thank you.